Hello, and welcome to this quick take video on the Xilinx Software Development Kit. As we'll show in this short video, the Xilinx SDK is a full complement of tools for all your embedded software development needs. Software engineers do not need to cross over to the hardware domain and master unfamiliar design methodologies. You will feel at home with the Xilinx SDK right from the start. We'll take a quick look at the SDK development environment, creating board support packages, developing applications, debugging and optimizing, interacting with the hardware and programmable logic, and Linux development. The Xilinx SDK is easy to learn and contains all the tools you need for world-class software deployment on the Zynq family of all-programmable devices. It is tailor-made for a broad range of software disciplines, ranging from board bring-up to driver development to bare metal and Linux application development. Each of these developers will find the right tools with the customization they need to create, debug, and deploy their part of the project. The Xilinx SDK is based on the familiar Eclipse development environment and makes use of GCC tools from Code Sorcery for both bare metal and Linux development. These are industry-standard embedded tool chains that you may have already used on other projects. The code development perspective provides common features like syntax highlighting, information consoles, project file management, an outline view for your code, and quick buttons, all for an intuitive workflow. The debugger comprises of all the widely expected tools, including detailed variable inspection, breakpoint management, core register viewers, and complete debugging at the C, C++, or assembly levels. It also includes support for heterogeneous and multiprocessor debug. The SDK offers a familiar, well-established workflow that can be managed through command line scripts or easy-to-use wizards. It fits to your workflow, not the other way around. With ever-evolving hardware, software engineers worry about constant revisions to the low-level drivers and API for the processor and custom hardware. The SDK solution is simple. The hardware definition is passed to the software team through a single hardware definition file extracted from the hardware build. The SDK uses this file to extract register maps, processor and peripheral configurations, and creates a comprehensive board support package and API. With the HDF, the board support package is just a few mouse clicks away. With the Xilinx SDK, bringing up a board for the first time and creating applications is easy. The built-in tools provide initialization files and tested bare metal drivers for all the Zynq peripherals. With just a few clicks, you can create a board support package. Additionally, you can create basic applications for standalone or Linux using the template files provided. With source code in hand, you could extend these example applications to aid you in verifying the functionality of your board or as the starting point for your own application. Linux application development for the Zynq platform is similar to other Linux development processes that are hardware and platform independent. The procedure for creating applications in the SDK workspace is similar to the standalone platform, except the Linux platform BSP is selected. Linux development and debugging can be executed in the SDK or in an external Linux development environment. The PetaLinux tools offers everything necessary to customize, build, and deploy embedded Linux solutions on Xilinx processing systems. Once a file system has been created with these tools, the SDK provides easy integration for application development and debug. Debugging your applications is easy with the debuggers provided in the Xilinx SDK. You have a choice between the standard GDB for application debugging or the advanced Xilinx system debugger for bare metal debug. Debugging can be as simple as stepping through code or as complex as debugging symmetric or asymmetric multiprocessing systems on the Cortex-A9s. The tool also supports heterogeneous multiprocessor debug when you include one or more microblaze soft-core processors in the programmable logic. You can readily debug multiple processors simultaneously with a single system debugger debug configuration. Ever wonder what the hardware outside your application's processor is doing in response to your code? With the Vivado Logic Analyzer, you can stop program execution based on a hardware trigger or see what is happening in the programmable logic when you reach a breakpoint in your code. After you have your code working, it is important to understand its runtime characteristics such as speed, memory, and resource usage. The Xilinx SDK provides an extensive collection of graphical performance modeling and profiling tools that allow live, continuous display of results from within the processor system or at the interface between the processor and the programmable logic. You can use this information to find the critical pieces of code and optimize their performance in the design. Once the code meets performance requirements and is ready for deployment, it is necessary to create the appropriate boot mechanism. The Xilinx SDK provides a number of tools to create bootloaders such as the first stage bootloader or U-boot for Linux. All these can be conveniently packaged using the Xilinx Bootgen tool. Bootgen creates a bootable image from a set of ELF files and programmable logic bitstream files to create a single image that can be loaded to Flash. Additionally, the SDK has a tool for writing your Flash image to common Flash devices. With this quick tour of the Xilinx SDK, we have shown that it is a complete set of tools for developing world-class embedded software for the Zynq family of all programmable devices. From the easy creation and maintenance of board support packages to bare metal or Linux application development and debugging, the Xilinx SDK supports all your needs from concept to deployment. There are a number of user guides and other quick take videos on the Zynq software development process. Use the documentation navigator, DocNav, or search the Xilinx website for these resources. This completes the video on Xilinx SDK. Thank you for watching.